Hello mates, welcome to my channel again. Over here you can see an example of non-convex polynomial programming. So basically we have to minimize a function which is non-convex, as you can see it. This problem belongs to a series of problems that appear in a book called Global Optimization. The author is Sherali. I will give you the details of this book, in which basically he develops a way of solving that kind of problems, right? But I'm going to just sort it out by a different approach. Looking at the function, you will appreciate that the function is also different convex. So we can establish two separate parts. One is convex and the other is non-convex. And what we can do is convert this optimization problem into a different convex programming problem, which is different it's different in a way. And to do that, we need at least one of the constraints to be convex reverse. In this case, we got the second constraint, x1 plus 2x2 plus x3 greater or equal than 1. That can be considered in this way, and also taking into account the upper and lower bounds and the first constraint. We have a convex set over here, so we can apply this, we call it a shortcut to minimize this problem. What I'm going to do is show you how to do it. Let me write this problem then in an appropriate manner using the difference convex theorem. So to solve this problem as a difference convex programming problem, what we can do is maintaining as an objective function the convex part of the original function and moving as a constraint the non-convex part of this function, which is minus 2 times x1 times x2 minus 3 times x1 times x3 plus 5 times x2 times x3 minus x3 squared, okay, less or equal than 0 because we want to minimize it anyway. So, and also I'm adding and subtracting an artificial constraint, which is hyperparabolizing this problem, x4, call it, for example. And this should be equivalent. Let's solve it to see what it gets. As you can see, we get x1 being 3, x2 being 0, x2 being 0, and x3 being almost 8, which is the correct solution. Well, this is more or less what happens in the true problem. In the original optimization problem, the objective function is minus 119, and this 7.96 in the variable number 3 is at 8, in fact. But the technique works, which is the important thing I was going to emphasize. So this is a way of solving this problem, and believe me, it's much more easy than the approach of using polynomials, right? So just keep it in mind. Well, for this time, this is enough. I hope you enjoy and have a nice weekend. And we will continue in new videos explaining, well, topics related with non-convex optimization. Thank you. Bye-bye.